Okay, why the area under velocity timeline graph is considered the distance? So there are a lot of reasons, but I want you to consider two things. First would be theoretical, and second would be just like by knowing using the formula, right? And let's say knowing the reason behind it. Okay, I will start by just drawing a graph right there. So as we know, we have two formulas that are related to velocity and timeline graphs. In timeline graphs, and that would be finding acceleration, which is velocity divided by time, and distance, so that would be velocity multiplied by time. I mean, there are a lot of other formulas regarding this timeline graph, but for the, let's say, physics bootcamp start, we should know those two. Okay, so one thing I want you to notice is that it might depend on the velocity and constant, if the velocity is constant or is changing, or if it's instantaneous or not. Let's say that our velocity is, let's say, 6, right? 6. Okay, 1 2 3 5 6. Okay, let's just start from there, and the time is 8, right? So that would be right there, right? Okay, I want you to pause the video and find the distance by yourself. So the shape that we're, let's say, drawing should be square, right? Because the velocity is being just constant and it's not changing at all. That's why our velocity is not changing. Velocity is just holding on to still in 1, right? That's why it would be a square. And in order to find, let's say, velocity, we need to just, not velocity but distance, we need to just multiply velocity by time. So that would be velocity over time, and that would be 48, right? Okay, now we're having another case when the velocity and timeline graphs are the same, but velocity is changing over time. What do I mean by that? Look, when the velocity, let's say, we might have initial velocity, and that would be 0, and as I've marked before, that would be 0, and the final velocity is, let's say, 7, right? Okay, 7, and the time is 5. So that would be, as logically speaking, that would be velocity over time, but this case is different because the velocity is changing, and as we know, we should change the velocity over time, and the final velocity would be on the 5th second. Okay, okay, let me change the marker. That would be 1 2 3 4 5, right? That would be the final point, and here is 7, right? Okay, here's 7, right? So that would be like this. The timeline graph is now different because we're not having a constant velocity, and we're not just staying in one velocity, and we are changing it throughout the time. That's why formula for that case would be velocity over time multiplied 1 by 2. Okay, now in this case we are doing this. You might ask, why not this place, right? Because time is always positive, should be always positive, and it cannot be negative. That's why you should highlight the place that is closer to the timeline. That's why 35 divided by 2, 7, 5, that would be 35, right? 35 divided by 2, that would be 17.5. So the answer is 17.5. That is the difference between, let's say, square shaped. Okay, let me just draw a formula for you. say square shaped distance, and that would be velocity over time, and triangle, that would be velocity over time divided by 2. Okay, let me change the color. So that would be velocity over time divided by 2. So yeah, I wanted to solve some problems on Khan Academy on this case, and I guess I will pin the link below or just mention the course so you can solve it by yourself. So yeah, bye.